Okay, so I don't know if you guys have ever heard of Roswell, New Mexico, and I don't know how you feel about aliens, whether aliens exist or whether they don't exist. Personally, I have no idea, and I don't really spend a whole lot of time thinking about it. But I do know that I know some of the claims of the people who believe strongly in aliens. It's a fact that there was a police officer who no one ever questioned his honesty or integrity, who found materials on a crashed thing in Roswell, New Mexico, back in, oh Lord, around 1950. And it was like stuff that he had never seen before. There's a picture in the upper left of him with this material. And he, not just he claimed, but as you can see in the newspaper on the right hand side, um, they claimed that it was a flying saucer that landed there. And that's really the backbone of much of the UFO hysteria, if you will, that you find people who strongly believe in UFOs. This is what they really gather in. Now, again, I have no idea. I really don't know. Supposedly, according to the government, it was a weather balloon, and that was what the guy found. Who knows? Maybe these things that we call UFOs are indeed UFOs, unidentified flying objects, but maybe they're not alien in origin. Maybe they're from like the government with military research and development, and they're trying to come up with new weapons and new ways to fly and so on. So I really don't know. And like I said, I don't take much time thinking about it. But some of the things that make me chuckle is that supposedly from this Roswell incident, we came up with Velcro. I don't know, but supposedly. And the other thing is, whether you believe in aliens or not, and whether it's just coincidence, who knows? But there are those who feel that from the time of the Roswell incident, you can trace back major technological leaps that we did not have before Roswell. And their theory is that we did this thing called reverse engineering. And what reverse engineering means is that supposedly we captured the flying saucer and we put our engineers on it, and all of the working information was there already. So they just went backwards to try to figure out how this technology worked so that we could then forward engineer, build it back up again and come up with our own designs. That's one of the things that people were very upset about, the way that we left Afghanistan a while back, is that our military leadership, in what is universally considered a terrible mistake, left some of our weaponry there that no other country in the world has. And the fear is that those countries can then reverse engineer and catch up to some of our technological advantages. So this reverse engineering thing is a very real phenomena. And whether or not it applied to Roswell and aliens and our society, I have not a clue. I really, truly don't know. And like I said, I don't spend much time thinking about it. But it's a really good analogy for understanding what factoring is. You see, factoring is to anti-distribute. In a sense, it's division. Distributing is multiplication, and factoring is division. But I don't like the name because students, immediately you say division, students are uncomfortable with it. I like the term reverse engineer or anti-distribute. I'll show you what I mean. Let's just distribute 5 times A plus 2B. If we do that, 5 times A is 5A, 5 times 2B is 10B. So let's have you go and distribute for all four of these examples. Okay, so the first one's 21n minus 12. The next is negative 2x minus 8y plus 10. The next is negative 21x squared minus 28x plus 7. And the next is 18x cubed plus 27x squared minus 36x plus 45. Now, if you thought there was not enough time there, please remember, always do stop and start. Okay, so that's great. What we have done so far this year is we've begun with the leftmost column in black, and we've asked you to figure out the rightmost column in red. Now that we're learning how to factor, we're going to do things exactly the opposite. We're going to start with the column in red on the right and ask you to develop the column in black on the left. In other words, we're going to ask you to reverse engineer. If you started out with the finished product, the flying saucer, if you will, of 5a plus 10b, I need you to come up with 5 times parentheses a plus 2b. And the way we do that is we look for the common factor. In fact, we look for the greatest common factor. And then once we find that greatest common factor, we just factor it out. So remember, factoring is anti-distribute. So in the first one, they share a 5 in common. Now, they don't share a letter because A and B, there's nothing in common there. But they do share a 5 between the 5 and the 10. So I factor out the 5. And here's the biggest thing. Like Nike says, just do it. Take your guess. 5 times a plus 2b. 5 times a is 5a. 5 times 2b is 10b. Next one, I look at 21n minus 12, and I notice they share a 3 in common. Sharing a 3 in common, that's 3 times 7n minus 4. Next one, I notice that they share a 2 in common, or a negative 2, however you want it to look at it, and it can work both ways. I factor that out, and I get negative 2 times x plus 4y minus 5, and so on. So this idea of ending up with the finished product and breaking it down to what you must have started with is like reverse engineering. It's anti-distribute, and that is factoring with the greatest common factor. Okay? So we said that in the first example, 5a plus 10b, they shared a 5 in common. So we factored out that 5, and we were left with a plus 2b, and we apply that to all the others. So now we have a bunch of examples. Let's take a look together at this first one. What do they share in common, 5n minus 20? Well, they share a 5 in common. So we're going to do anti-distribute here. And like I said, Nike says, just do it. So they share a 5 in common. So I'm going to guess that what goes into parentheses is n minus 4. And then what you do is you just distribute back and check yourself mentally real quick. You don't have to write it out. 5 times n is 5n. 5 times negative 4 is negative 20. You try the next one, number 2. Okay, so for number 2, there's lots of numbers they share in common. They share a 2, a 3, a 4, a 6, and a 12. The greatest of those common factors is 12. So I'm going to factor out the 12, and I'm left with g plus 2, I think. Let me check myself by distributing back. 12 times g is 12g, 12 times 2 is 24. To arrive at that conclusion, I'm really asking myself, what's 12g divided by 12? It's g. And what's 24 divided by 12? It's 2. But whatever you think it is, if you just put it in there and check yourself back, you'll realize your mistake as soon as you make it. Okay? What we're looking for you to do here is identify the greatest common factor and anti-distribute. Pull it out, divide it out. Okay? Number 3, give it a shot. Remember, we are doing stop and start. So in this case, they share a 4 in common. And I think it's 3x plus 7 left over. Let's check myself. 4 times 3x is 12x. 4 times 7 is 28. Of course, 12 divided by 4 is 3, and 28 divided by 4 is 7. So yes, that checks. And I'm really big on this quick mental check. It's very, very helpful. Try number 4. Okay. So in number 4, they share a 5 in common, I think. So I'm going to divide out or factor out. So from the first one, that would leave 1a minus 3b plus 2c. Checking myself back, 5 times a is 5a, 5 times negative 3b is negative 15b, and 5 times 2c is 10c. So in each of the cases for numbers 1 through 4, the greatest common factor always worked out to be a number. For numbers 5 and 6, now the greatest common factor is not a number, but rather it's a letter. See, in number 5, they both share an a in common. So I'm going to pull out, factor out, divide out that a, and I think what's left is a plus 3, but let's distribute and check ourselves. A times a is a squared, a times 3 is 3a, so I get a squared plus 3a. Remember, we are anti-distributing. We're simply going backwards. Reverse engineering, if you will. Number 6, what do they share in common? Well, clearly they don't share a number in common because there's no number in front of the a squared. But they do share an a in common because both terms have an a. So I factor out that a. I think it's a minus 7. Quick mental check. A times a is a squared. A times negative 7 is negative 7a. So that checks. So in numbers 1 through 4, in every problem, they shared a number in common. In numbers 5 and 6, in each of those two questions, they shared a letter in common, a variable. In number 7, they share both. What do you think they share in number 7? Just the greatest common factor. Let's not go for the whole answer. Well, they share a 5, and they share an A. Now you try to come up with the answer. Go ahead. Okay, so factoring it out, they share a 5 and an A in common. So there's my greatest common factor. That always goes outside the parentheses, and let's check it back. 5a times a is 5a squared. 5a times 3 is 15a. And that makes sense, right? Because a squared divided by a leaves an a. 5 divided by 5 is just 1. 15 divided by 5 is 3. And the a was pulled out, if you will, leaving no a's left. You can look at it in the first part of this binomial, in the parentheses. A squared is aa. You pulled one of them out. That leaves one behind. Okay, let's try number 8. And also number 9. Go ahead, try 8 and 9. Okay, so for number 8, they share a 5 in common between the 10 and the 25, and they share 1x. So 5x is my greatest common factor, and 2x minus 5 is left. Let's check and distribute. 5 times 2 is 10. X times x is x squared. 5x times negative 5 is negative 25x. So that's correct. Number 9. The difference in number 9 is the first term has a v, the second term has a v, but the last term does not. So I can't pull out any letters here. I can only pull out what they share in common, which is a 3. So it's 3 times v squared minus 3v minus 7. Okay, you try number 10. Now, the new step on number 10 is they share this pi symbol in common, which is a very strange symbol. We would not have expected to have seen it, but they do share a pi in common. We'll pull out one of those. And they also share an r in common, so we'll pull out one of those. So I'm going to pull out, factor out, divide out the pi r, and pi r times r is pi r squared. So far, so good. And pi r times h is pi r h. So that works. Number 11. Try it. Now, the tricky part of number 11, there's an easy part and a tricky part. The easy part is that they share a 4 in common. The tricky part is how many n's do they share in common? The first term has 5 n's, the second term has 3, and the last term has 2. In other words, n to the fifth is n, 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 n. The next one is n, 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 and the last one is n, n. Now, this is called the greatest common factor. And that term greatest, that makes us want to pick the most, but common. They all have to have it. So the first term, yes, it has n, 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 but the last term doesn't. Neither does the middle. You're always going to choose the smallest exponent here when it comes to what they share in common, because all of them have at least n squared. That is, all of them have at least n. But all of them don't have n cubes, and all of them don't have n to the fifth. So my common factor, my greatest common factor, is 4n squared. Now let's distribute back and see if we got it right. 4 times 2 is 10, n squared times n to the third is n to the fifth. 4 times 5 is 20, n squared times n is n to the third, and 4 times negative 8 is negative 32, and n squared. Perfect, works great. Similar idea, try it on number 12. Okay, so in this case, they share a 3x in common. Distributing back, 3x times 3x squared is 9x cubed. 3x times negative 27x is negative 21x squared, and 3x times 5 is 15x. So that's what we call factoring using the greatest common factor. That's one type of factoring. It's the fundamental type, and we need to know it. But just like we did distribute, we've also done double distribute. So let's take a gander at reviewing a little bit about double distribute. Let's have you do all 6 of these, and I'll give you the answers in just a minute. Okay, so for the first one, it works out to x squared plus 8x plus 15. The second is x squared plus 9x plus 14. The next one is x squared minus 8x plus 15. The next one is x squared minus 11x plus 24. Next, number 5, x squared plus 7x minus 18. And number 6, x squared minus 7x minus 18. Now, what I want to do is look for some observations here. Look for some trends through these questions. And the first thing that I notice is that in every single case, if I look at the last two terms of the binomial, 5 and 3, I got 15. 7 and 2, I got 14. Negative 3 and negative 5, I got positive 15. Negative 8 and negative 3, I got positive 24. 9 and negative 2, I got negative 18. And negative 9 and 2, I got negative 18. In every single case, you multiply to equal the last term. And then 3 plus 5 is 8. 7 and 2 make 9. Negative 3 and negative 5 make negative 8. And so on. You add to the middle term. So this gives you what we call the AM method. In other words, if I reverse engineered a double distribute problem, and I started with just x squared plus 8x plus 15 and said, what two binomials did I have to begin with? How do we know that they're x plus 3 times x plus 5? And the way you know that is that in your final answer here, x squared plus 8x plus 15, you multiplied 3 and 5 to get 15. So you multiply the last two terms to get 15, and you add 3 plus 5 to get 8. That's why it has to be 3 and 5. It can't be 15 and 1. Okay? Has to be 3 and 5, can't be 15 and 1. Because that's the only combination of numbers that multiplies out to 15 and adds up to 8. So we can use the AM approach. If we take a look at number 7, what two numbers multiply out to 14, because here's my term right here, and add up to 9, 7 and 2. Let's take a look now, jump forward to number 4. Let's look at the answer. It was x squared minus 11x plus 24. If we just focus on the last part and say, well, what two numbers multiply out to 24? Remember, it's AM. We add to the middle, multiply to the last. If I look for ways to multiply out to 24, there's 1 times 24, 2 times 12, 3 times 8, 4 times 6. Then I say, well, which one of those combinations adds to negative 11? Well, that would be negative 8 and negative 3. So that AM approach is what determines the unique pair of binomials that you have to start with. If I look at number 5 and 6 and compare them, I see an x squared, a 7x, and an 18, and then it's just the positives and negatives that switch around. So I have to multiply out to negative 18, which means it could be some combination positive and negative of 18 and 1, 2 and 7, or 3 and 6. But if you notice, I'm adding up to positive 7, so it has to be positive 9 and negative 2, because that's the only combination that adds up to positive 7. Whereas the answer to number 6, you have to add up to negative 7, because they're negative 9 and positive 2, and that adds up to negative 7. Now, I'm sure you've done a lot of this in high school, and that should be more or less a comfortable review for it. But I want you to know something. You can do this on your graphing calculator. How do you do it on the graphing calculator? Well, the first thing you're going to do is you're going to go into your y equals button, okay? And when you go into y equals, you're going to type in two different things. So first, clear out your y equals. And then you're going to take whatever the last number is, include the positive or the negative, and put divided by x. So let's just do this together, assuming you have a graphing calculator. And if you remember earlier in the year, I said I strongly suggest you get one. We have hit the time of year where I strongly suggest it. If we do number 6 together, if I take my last number of the answer, the trinomial, x squared minus 7x minus 18, I'm going to type in negative 18 divided by x. And the x button is, you see the blue second button and the green alpha button? Well, it's to the bottom right of the blue button and to the right of the green alpha button. And you'll see a button that says xt theta n. That's your x button. So for number 1, I type in negative 18 divided by x for y1. Now I go to y2, and for y2, I put whatever's in y1 in parentheses. It has to go in parentheses. So parentheses, negative 18 divided by x, close the parenthesis, and then you're just going to type in plus x. So you just put in plus x, and then we're not going to go to graph. I don't want to graph this. I want to go to table. So hit the second button, and then in the upper right-hand corner, it goes to table. And now you're just going to look at the y2 column, and when you look in y2, look for the middle number or the middle term. In this problem, it was negative 7. So just scroll up and down until you find negative 7 in the last column. There it is. In the last column, y2 is negative 7 when the first two columns are minus 9 and plus 2. And that was the original answer. Look at the two binomials or the original question. It's x minus 9 and x plus 2. So we have reverse engineered what we must have started with. So again, maybe take a picture of this screen so you don't lose track of it. When you do it on the graphing calculator, y1 is always the last number divided by x, positive or negative, don't forget that. y2 is always the same exact thing as in y1 in parentheses plus x. So let's do some examples here. Let's try number 8. I'm looking for two numbers, and I'll use AM on this one. I'm looking for two numbers that multiply out to equal 20 and add up to equal to 9. What two numbers multiply out to 20 and add up to 9? Well, 1 times 20 is possible. 2 times 10, no, that didn't work. 5 and 4. So 5 and 4 work. So my answer is x plus 5 and x plus 4. Now, if I was doing it in the calculator, under y1, I would put 20 divided by x. You just take whatever the multiply is. Under y2, I do the same exact thing plus x. And when you do that, you will see that it comes out to 5 and 4. Remember, I look for the middle column. I look in the last column of the table for 9. And when I find the 9, I look back at the two previous columns and they'll say 5 and 4. In either order, it doesn't make a difference. Okay, let's take a look now at number 9. I want to multiply out to 20 and I want to add up to 12. So what two numbers do that? Well, we just discussed the ways to multiply out to 20 and we said, hey, you know what? 10 and 2. So I get x plus 10 times x plus 2. What would you do if you're doing it in the calculator? Under y1, remember the m goes first, it would always be 20 divided by x. And then under y2, you're still going to type the same thing, 20 divided by x plus x. But the difference is this time, in that last column, you're going to look for the 12. You always look for whatever it adds up to in the last column. When you look for the 12 and you find it, you look in the two previous columns, it'll tell you 10 and 2. So let's see you try number 10 and 11. Just do 10 and 11. Go ahead. So for number 10, I have to multiply out to negative 18, add up to negative 7. The two numbers off the top of my head that can do that are negative 9 and positive 2. And now we're getting into the realm of discomfort because many students in math are not overly comfortable with doing all of these calculations in their heads. So if you're comfortable with it, by all means, realize the two numbers that multiply out to negative 18 and add up to negative 7 are negative 9 and 2. So in my pair of binomials, I get x minus 9. There's my negative 9 taken care of. X plus 2. There's my 2 getting taken care of. But if you're not comfortable in your head dealing with integers and division and products and so on and so forth, just go in your calculator. Under y1, you put in parentheses. I like to put negatives in parentheses always, so I never worry about when I should and shouldn't do it. Negative 18 divided by x. Under y2, same exact thing as y1 in parentheses plus x. When you do that, you look in the middle column for you look in the last column for a negative 7, and you'll find the previous columns say negative 9 and 2. For number 11, I'm looking for to multiply out to negative 10, add up to negative 9. Well, if you know off the top of your head that that's negative 10 times positive 1, beautiful. That gives you the answer of x minus 10 times x plus 1. People who are really comfortable with their number facts like that, they tend to be very good at factoring. But if you're not as comfortable, it's not the end of the world. The power of the graphing calculator, some of the best $100 you'll ever spend in your life. Y1 is negative 10 divided by x. And again, anytime I put a negative in a calculator, graphing calculator, I like it to be in parentheses. Doesn't have to be sometimes, but that's the problem. Sometimes it does, sometimes it doesn't. If I always do it, I never have a problem. For y2, I take whatever it says in y1 and I just put plus x, always making sure it's in parentheses whether I like it or not. And then I look in the last column for a negative 9, and the previous columns will say negative 10 and positive 1. Okay? So now you try numbers 12, 13, and 14. Go ahead. Okay, number 12. Two numbers that multiply out to negative 40 add up to negative 3. Those would be negative 8 and 5. So that means the factors are x minus 8 and x plus 5. I just put them next to the x's. If I used my calculator, the first column, y1, the first equation would be negative 40 divided by x. And y2 would be the same exact thing plus x. It's always for y2, the same thing as in y1 plus x. And y1 is always the last number divided by x. And if it's a negative, you should put it in parentheses, just as a good habit to have. Next one, number 13. I multiply out to negative 12. I add up to 1. So, what two numbers multiply out to negative 12? I'm sorry, I did that, reverse it. Whatever I said before, ignore it for a minute. I need two numbers that multiply out to negative 12, add up to 1. What two numbers multiply out to negative 12 and add up to 1? That would be a negative 3 and a positive 4. That means my factors are x minus 3 and x plus 4. If I do it on the calculator, for y1, I'm going to put negative 12 divided by x. And for y2, I'm going to copy the same exact thing, except I'm also going to add plus x. I look in the last column for a positive 1. The previous columns will say a negative 3 and a positive 4, in either order. And number 14, I'm going to multiply out to equal a 6, add up to a negative 5. This is a very common one for students to get wrong because they think 6 and 1. But 6 and 1 can't multiply out to a 6 and add up to a negative 5, positive 6. Because if you multiply out to a positive 6, the signs have to be the same. So it actually works out to be negative 2 and negative 3, which means I get x minus 2 and x minus 3 as my factors. If I did it in the calculator, y1 would be 6 divided by x, and y2 would be the same exact thing in parentheses plus x. So that's how we factor a fundamental trinomial using AM or the graphing calculator, whatever you are happy with. So as far as a recap, you know what? I forgot to do the slides. This is mostly a review of the stuff before factoring, and I'll verbally address factoring. Combining like terms is like laundry. You gather up your like terms, you combine them, and if they're not the same kind of term, you keep them separate. So in other words, you have your hoodies in one pile, your jeans in a pile, your sweaters in a pile, socks in a pile, and so on. If you need to distribute, you do so first whenever you try to simplify an expression. If there's a number outside of parentheses, always distribute before you simplify. If you're subtracting, don't forget to distribute a negative sign across the parenthesis that follows the subtraction. That's when dealing with polynomials. And for double distribute, you always look to combine those terms in the middle. Now, for factoring, we've got, for division, don't worry too much about it, but it can be done just like elementary school. As far as factoring goes, there's two techniques. There's the greatest common factor, where you look for it and you pull out the greatest common factor, check yourself by multiplying back. And then there's when you factor a trinomial and you're looking for a pair of binomials that started. And we have the AM technique or the calculator technique to work on that.